Okay, class, today we're going to be talking about section 12.1. This is going to contain a lot of verbiage throughout the rest of the chapter that you're going to need to know. Let's first start off with what is known as a polyhedron or polyhedra. These are solids with all flat faces that encloses a single space of region, or single region of space, if I can talk right. So basically what I'm talking about, your cube. All of its faces are flat, and it encloses a region of space. Okay. Another thing I could be talking about is a pyramid. Okay, like our Egyptian pyramids. Okay, the faces are all flat, and it encloses a region of space. Okay, something that are not polyhedrons would be a cylinder. Okay, because my faces are round. See, these are round faces, so it's going to create round sides. Okay, another thing that is not a polyhedron is our cone, because our base is round, it is not flat. So these are not polyhedrons. Okay, now a face, what's known as a face? A face is the space figure, the faces of a space figure are the flat sides of the figure. I'm going to draw my cube again. And as you're going to see, as these shapes get harder, so does my artistic skills go down the drain. Okay, so a face would be this right here. So in a cube, we have 6 faces. Okay, for my triangle here, or for my triangular prism, this right here would be a face. This right here. Another face would be this right here, or the base that is a square. That could be a face as well. An edge are the line segments where the faces meet. So in my cube, this line right here is an edge, because this face and this back face right here, when they intersect, when they meet, they form a line. Okay, see that? So this is an edge, that is an edge. All of these line segments here are edges. Okay, the next thing that we need to know is a vertex. Vertices are the corners or the points of intersection of 3 edges. Okay, so with my cube, let's keep the same theme going here. Where 3 edges meet, I have a vertex. So 1, 2, 3. I have a vertex. So all of these points here are vertices of this cube. And there are 8 vertices in all in a cube. Let me go back here and say in this cube here we have 12 edges in all. So 12 edges in all for this cube here. I forgot to do that. Now we're going to go on to our base. The bases are 2 ends of a prism or a cylinder, or its bottom, or it is a bottom of a pyramid or a cone. Okay, so let me draw a prism real quick. So a prism, okay, actually I'm not going to draw a prism, because a prism is just, you have your cube and you have your rectangle. Those are prisms. Okay, your cylinder Your cylinder, this would be the base of your cylinder here. Your circles, the circles of the cylinder. Okay, for a pyramid, this square is the base of your pyramid. So there's only one base in a pyramid, and there's two in a cylinder. In a rectangle prism, you have two bases. Okay, and also in our prisms and cylinders, our bases are congruent. Bases are congruent. Okay, and there's two of them. So here there's two bases that are congruent. Now, this region right here is not considered a base because there's four of them. Okay, so it's only the two faces that are congruent. Okay, next, a pyramid is a polyhedron that has all faces except one intersecting at one point. Okay, so if we look right here, this pyramid, all of its faces intersect at this top point right here. All of them intersect at this top point except for the base. The base is the face that does not intersect at a common point. Okay, a prism is a polyhedron with two congruent faces that are polygons contained in parallel lines, and that is what I drew here. Okay, it has two bases that are congruent. Two faces that are congruent and contained by parallel lines. So these lines right here contain my base, and they're parallel as well. Okay, we name our prism by the shape of its bases. So we name a prism by the shape of its bases. Okay. Moving on, a theorem that we're not really going to have you practice, but one that you need to be aware of. It might save you time later. It's called Euler's theorem. Yes, it's pronounced Euler. I went all through college calling it Euler's theorem, and my professors looked at me like I was crazy. They failed to tell me that it was pronounced Euler, so I will enlighten you here. Okay, so Euler's theorem tells us that the number of faces plus the number of vertices equals the number of edges plus 2. Okay, and this is true for all polyhedrons. Okay, this works every single time. So for instance, for a square that we were working with, we have 6 faces, okay, and we have 8 vertices, and then we have 12 edges, and then if we add that to 2, we equal here. We get 14 equals 14. And this will work for a pyramid. It will work for a hexagonal prism. Okay, it works for all polyhedrons. Okay, the next thing we need to know is a regular polyhedron. This is a polyhedron whose faces are all congruent. Okay, so I'm going to try and draw an equilateral pyramid here, but we're going to see. Not all that talented. So just imagine that all of these faces here, all of these sides are the same. And that's what you need to remember, is that every face is congruent, and in this picture, every face is an equal lateral triangle. Okay, our last, or 2 more. Convex polyhedron, a polyhedron such that any 2 points on its surface can be connected by a line segment that lies entirely inside or on the polyhedron. So if I take a cube here, and I want to draw a line and connect these two dots, my line is going to be inside or it's going to lie on my polyhedron. Now, this would be convex. Now, if I wanted to draw a concave polyhedron, basically, if I wanted to connect 2 points, a line might lie outside of the circle, or not outside the circle, outside of the polygon, or outside the solid figure. Sorry, let me get my terminology right. So if I wanted to connect these 2 points here and I draw a line through it, this line is outside my solid. So this would be a concave polygon, or concave solid. Okay, now a cross section, I'm going to tip my best to show you what this looks like, but I recommend looking in your book because they have great pictures. But basically a cross section is if you were to take a plane and you were to cut a solid figure in half, if that figure that you cut, or if you were to just extract that, you're going to get a shape. So let me draw a triangular prism here. Okay, if I was to draw a plane that was parallel, imagine that this plane is parallel to my base, my cross section would in fact be the base. So it would be a shaded region and it would look something like that. Okay, that is it for 12.1, and I will see you in class.